For those of you that just joined us, we have a bell work today. You still have enough time to practice with that. From our class Canvas page, you want to click on the big green button for today's lesson. That'll take you here. You're going to click on the unit circle, and that's going to take you to an outside web page. You need to scroll down until you can actually see the unit circle there. Play the quiz. It's got a 2-minute timer. For those of you that want to practice to see if you can do it faster and faster, there is a stopwatch option on the timer before you click play quiz, if you want to see how fast you can do it. So you want to play the quiz. It'll give you a radian measure, and you need to click on the angle that would be correct. If it shows up red, it means that you missed that one. If you got it right, then it's green. After you put one in, it will give you the next radian measure. So we're going to do this for about another 1.5 minutes, and then we're going to move forward with the lesson. But I do want you guys to be getting in some practice with those. When we do the timed in-class quiz over the unit circle, you guys are going to only have about 3 or 4 minutes to fill the whole thing in. So speed is key. All right, guys, we do need to move forward with the notes. I would recommend making use of that online tool to practice getting faster and faster at your unit circle. I'm going to try to find some more little online quizzes like that to help you practice with your speed. When you do this in class, it will be a fill in by hand, but at the very least, those online tools are going to help you know the location of these different angle measures in radians and in degrees. All right. In your notes, we are going to start off by finding the 6 trig function values of an isosceles right triangle. What does isosceles mean? What does isosceles mean? We're supposed to draw an isosceles right triangle. Triangle with 2 equal sides. Yes. So I can draw my isosceles right triangle, at least to the best of my ability here. See if I can get that to be. All right. So these 2 sides are equal. I have a right angle down here. If I have an isosceles right triangle, how big are my angles? How big are my acute angles? 45 degrees, yes. Isosceles means that the base angles are going to be equal. So when we're talking about these trig values, it does not matter which angle I'm standing at, because they're both the same. They didn't tell us in the problem how big any of the sides of this triangle are, and so I'm just going to call these 2 congruent sides x, and I can use that then to figure out how big the hypotenuse is for any side length value. I'm going to use Pythagorean Theorem. A squared plus b squared equals c squared. We're looking for the hypotenuse here, so I'm going to have x squared plus x squared equals my hypotenuse squared. What is x squared plus x squared? 2x squared. Remember, when we are adding like terms together, it is the coefficient out in front that changes, not the exponent. The only way the exponent changes is if we are multiplying things. Now I need to take a square root. How big is that hypotenuse? How big is our hypotenuse? Yes. It's going to be x times square root of 2, or you can write that as square root of 2x. Either way is totally fine. I'm going to write this as square root of 2x. I have all the information that I need to be able to write down these 6 trig function values. So for the sine of 45 degrees, sine is opposite over hypotenuse. So what would my sine value be? Opposite over hypotenuse, what are we going to have? Remember, it doesn't matter which angle we're standing at. I could be standing down here, or I could be standing at the other angle. Doesn't matter, since they're the same size. I want to put opposite side over hypotenuse. How big is the opposite side? Yes, thank you, Jackie. So we're going to have x over square root of 2x. You guys see anything that's going to reduce? Very, very close, Brendan. Would anything reduce or cancel? Yeah, my x's are going to cancel. I do need to rationalize that denominator because we don't want to have square root of 2 down in our denominator. And so when I simplify that, I'm going to end up with the square root of 2 over 2. So there's my sine value. No worries. Yeah, 1 over square root of 2. What would my cosine value be? What is the cosine of 45 degrees? So now we're doing adjacent over hypotenuse. Same exact thing as sine. So it's going to simplify to be square root of 2 over 2. What about tangent? What will tangent be? 1, absolutely. Opposite over adjacent, that's going to simplify to just 1. All right, so there's the 3 that we are more familiar with. We want to do our reciprocal trig values as well. What is the reciprocal value, or sorry, the reciprocal function of sine? What is the reciprocal trig function of sine? Cosecant. So cosecant of 45 degrees. Now I would be doing hypotenuse over opposite. So I would have square root of 2x over x. And that's going to simplify to give me just square root of 2. What is the reciprocal trig function of cosine? What is the reciprocal trig function of cosine? Secant, thank you. What would the secant of 45 degrees be? Square root of 2. And what is the reciprocal trig function of tangent? Cotangent. What would the cotangent of 45 degrees be? 1. Absolutely. Reciprocal of 1 is 1. Perfect. Remember, in any of our reciprocal pairs, there's only one co. So sine has to go with cosecant, cosine has to go with secant, and then tangent and cotangent go together. Awesome. So there is one of our special right triangles. If you look at the triangle that we have this relationship between the sides. My two legs are going to be the same size. The hypotenuse is square root of 2 times however big the leg is. I want to go look at the other special right triangle. Type into the chat for me. This one is a 45, 45, 90. The other special right triangle is known by what angles? This one's a 45, 45, 90. Yes, 30, 60, 90. So let's go do our 30, 60, 90. We are going to start off with an equilateral triangle. What do you know about an equilateral triangle? All the angles are 60 degrees. What else? All the sides are equal. Absolutely. All right, so I'm going to do my best to draw an equilateral triangle here for us. There we go. I actually didn't do too bad that time. All of our angles are 60 degrees. And humor me while we do this. We're going to say that each of these sides, I don't know how big they are, but for the sake of this activity that we're doing, we're going to say that each side is 2x. All my sides are congruent. I want to take and write down the center of this equilateral triangle. I want to drop an altitude. Do you guys remember what an altitude is? What is an altitude? Yeah, goes from the top. So it's going to go from my top vertex. What's going to happen when it hits the opposite side? Not necessarily. This altitude will, but it's going to form a 90-degree angle. Altitudes will always form 90-degree angles. This particular altitude is going to split our base in half because we have those 3 equal sides. So yeah, that's going to turn it into a 30, 60, 90. So when I drop that altitude down, how big will this leg right here be? X, yes. Okay, I'm going to draw just that 30, 60, 90 so that I don't have too much of a hot mess going on here. Let's see if I can do this right. It's close. There we go. That's actually halfway decent. All right, so I've got my right angle right here, 60-degree angle over here, 30-degree angle up here. How big did we say the bottom of it was? X. How big is the hypotenuse? 2x. So the short side and the hypotenuse have this 2-to-1 ratio relationship. The long leg comes from our altitude, and I don't know how big that is, but I can use Pythagorean theorem to figure out the relationship between that long leg from our altitude as it relates to the short leg and or the hypotenuse. I'm going to do a squared plus b squared equals c squared. So x squared plus, I'm going to call that my opposite side because I'm going to stand over here at this 60-degree angle, is equal to, my hypotenuse is 2x, and then I'm going to square it. What is 2x squared? 2x times 2x. What is 2x squared? 2x multiplied to itself. 4x squared. Thank you, Jackie. And then I need to subtract x squared from both sides. What will I have over on the right when I subtract x squared? (3x squared). And then I need to take a square root of both sides. And I'm going to simplify that. So how big is my opposite side? How big is my opposite side? Square root of 3x. Yes. Awesome. So I'm going to fill that in here. So square root of 3x. I think I need to shrink some things down a little bit. There we go. And now that I've got sizes for my entire 30, 60, 90 triangle, we can write our 6 trig functions for each of these angles. Notice, not only is it my short leg and hypotenuse that have this 2-to-1 ratio, but the short leg and the altitude, the short leg and the long leg, have a 1/√3 relationship. All right, let's do our 6 trig functions for the 60-degree angle first. So I want to do sine of 60 degrees, cosine of 60 degrees, tangent of 60 degrees. What is the sine of 60 degrees going to be? When I do opposite over hypotenuse, sine of 60 degrees, what will we get? Yes, square root of 3x over 2x. Just like before, I'm going to see my x's cancel out. So I'm going to have square root of 3 over 2. What about my cosine? What is the cosine of 60 degrees? X over 2x. So when I reduce that, what do I get? 1/2. Cosine of 60 degrees is 1/2. What about the tangent? Tangent of 60 degrees. Opposite over adjacent. Write down SOHCAHTOA for us. Yes, it will come out to just be square root of 3 because I'm going to have square root of 3x over x, and then that's going to reduce, leaving me just square root of 3. Awesome. Now let's do our reciprocals. What will the cosecant of 60 degrees be? Two square root of 3 over 3. Yeah, we're going to start off with the reciprocal of sine. So that would be 2 over square root of 3. Have to rationalize our denominator. So multiply top and bottom by square root of 3. That's going to give me 2 square root of 3 over 3. Secant of 60 degrees. What are we going to have? What is the secant of 60 degrees? 2. The reciprocal of 1/2. What about cotangent of 60? Square root of 3 over 3. Absolutely, because we would have 1 over square root of 3. Rationalize that denominator. And so we're going to have square root of 3 over 3. When we did the 45, 45, 90 triangle, it didn't matter which acute angle we were standing at. We were going to get the same values for both acute angles. That is not the case here. I have a 60-degree angle, which we just did. But we also have a 30-degree angle. So I want to do the 6 trig functions for the 30-degree angle as well. What would the sine of 30 degrees be? So now I've moved and I'm standing up here now. Absolutely correct, Brendan. That's going to be 1/2. What's the cosine of 30 degrees going to be? What will the cosine of 30 degrees be? Square root of 3 over 2. What do you guys notice about our 30-degree sine and cosines in relationship to our 60 degrees? What's happening? Yeah, they're going to switch places. We changed where we're standing, so the opposite and the adjacent side are now flipped for us because we changed positions. So that's going to flip my sine and my cosine. What's that going to do to tangent? What will my tangent of 30 degrees be? It's going to flip with cotangent because, again, opposite and adjacent are flipped now since we changed positions. So now we're going to have square root of 3 over 3 as our tangent of 30 degrees. Let's go ahead and do our reciprocals. What's the reciprocal of sine again? Reciprocal of sine. Cosecant. Cosecant of 30 degrees is going to be the reciprocal of sine. So that was 1/2. So now that is 2. What is the reciprocal of cosine? Cosecant. No, not cosecant. Reciprocal of sine. I'm looking at the wrong spot in the chat. Sorry, reciprocal of cosine. Ugh. Secant. Secant of 30 degrees. What will the secant of 30 degrees be? Two square root of 3 over 3. Just like sine and cosine flipped, secant and cosecant flipped. And so what will cotangent of 30 degrees be? What will the cotangent of 30 degrees be? Square root of 3. When my opposite and adjacent switch sides, sine and cosine flip, secant and cosecant flip, and tangent and cotangent flip. All right, I'm going to take all this information that we've done about our special rights, and we're going to put this in a table. You need to make this table on your page as well. We are going to fill this in with all the information that we had. You guys are going to be responsible for memorizing this information. Most of this information ends up on our unit circle. And that's why I want you to take the time right now to copy it down into your notes. The more exposure you have to it, the easier it's going to be to remember. I'm going to go ahead and fill in the sine, cosine, tangent, cosecant, secant, and cotangent values for 30, 45, and 60. And then we're going to do our radian measures. So sine of 30 is 1/2. Cosine is square root of 3 over 2. Tangent is root 3 over 3. Cosecant is 2. Secant is 2 square root of 3 over 3. And cotangent is square root of 3. For our 45s, I've got square root of 2 over 2 for both sine and cosine. Tangent is 1. Cosecant and secant are both square root of 2, and cotangent is 1. For our 60-degree angle, sine and cosine of 30 flip, so I've got square root of 3 over 2, and then 1/2. Tangent is square root of 3. Cosecant is 2 square root of 3 over 3. Secant is 2. And cotangent is square root of 3 over 3. I know you guys are probably working on getting that copied down, but while you are doing that, I want to ask about the radian measures. This is one of the other reasons why I started off with that bell work quiz the way I did. 30 degrees is what in radians? Pi over 6. 45 degrees is what in radians? Pi over 4. And 60 degrees? Yes, Pedro, you absolutely need to be writing this down. You are going to need to memorize all of the information that's in this table, not necessarily in this form. You're not going to have to spit it back out in table form. all of this information is going to be used over and over and over and over and over, and a majority of it is on our unit circle, which you will be doing timed quizzes on. When you do the timed unit circle quiz, you're only going to get about 3 or 4 minutes to fill in the entire thing. It will be totally blank. You will need to fill it in with the degree markings. You will need to fill it in with the radian measures, and you will need to fill it in with the ordered pairs. We have done the angles in degrees and radians, and we've done 4 of the ordered pairs. We still have quite a few of the ordered pairs to fill in, and actually all of those ordered pairs come from this table right here. We're going to finish filling in your unit circle early next week, and then you guys will work on just practicing and getting faster and memorizing that, in addition to pushing forward with new information, new material. I'm going to give you guys about another minute with this. I will post these notes if you're not done. And you have all of this information from what we just did with the 45-45-90s and the 30-60-90s, but there's one more thing that we need to get written down before the end of the week, because we're going to use it next week. All right, I've got to get the next slide up. You do need to finish filling in that table. That is all information that you are going to need to be able to recall very quickly. All right, we're going to write down our fundamental identities. We are going to write down 8 identities. You guys are also going to be responsible for memorizing these. I would work over the weekend on memorizing these pieces right here and practicing your unit circle. The faster you get with these identities, the easier next week is going to be. We have 6 reciprocal identities. 3 of them are considered fundamental. Our 3 fundamentals: cosecant theta, that is the reciprocal of sine theta. Secant theta is the reciprocal of cosine theta. And cotangent theta is the reciprocal of tangent theta. We've been talking about those 3 already. So cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent. And then we have tangent and cotangent identities. Tangent theta is equal to sine theta divided by cosine theta. And cotangent theta, because it is the reciprocal of tangent, is cosine theta over sine theta. So there's 5 of the 8. 3 of them we've been working with a lot. We are going to prove the tangent theta equals sine theta over cosine theta identity. This one right here gets used a ton. And the first one of the Pythagorean identities also gets used an absolute excessive amount. All 8 of these are really important and you're going to need to memorize, or else you won't be able to do this next section at all. But if you want to focus on just 2 of them for right now, it's this one and the first Pythagorean identity. Before I write down the first Pythagorean identity, there's a little notation thing that I need to talk about. If I write sine squared of theta with the squared right after the sine, that means the exact same thing as sine theta inside parentheses squared. So sine squared theta is the same thing as saying sine theta times another sine theta. That is consistent mathematics notation. I'm not entirely certain why they settled on that, why they put the squared next to the actual function, but that is the notation that they've settled on. So whenever you see sine squared and an angle, we are taking sine of that angle and multiplying it by sine of that angle. All right. First Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. And if I had to pick out of these 8 really important fundamental identities, if I had to pick out the 2 most important, it is the tangent identity and that Pythagorean identity right there. Those are far and away the most important identities we're working with. There are 2 other Pythagorean identities. One plus tangent squared theta is equal to secant squared theta. And 1 plus cotangent squared theta is equal to cosecant squared theta. Those 8 identities right there are the fundamental trig identities. You need to commit those 8 to memory. And the faster and sooner you do that, the easier the rest of the semester is going to be. This weekend, you have a homework assignment due for me tonight. I can bring that page right back up if you need me to. But you have your 6.2 part A homework. I opened that up for you yesterday. First 4 questions is just writing down the 6 trig functions, 4 different descriptions of triangles, given different bits of information. The last 3 questions are using your special rights, which we went over today. In addition to that, you really need to practice your unit circle, practice getting those angle measures and those degrees down and matching those. And work on memorizing these 8 fundamental trig identities. On Monday, we're going to prove the tangent identity and all of the Pythagorean identities, because I want you to understand where they're coming from. And then we're going to use these to simplify and verify. I hope you guys have a fantastic weekend. Please let me know if you have any questions or any problems with the homework or anything else. Have a good one, guys.